Welcome to Chibuzor Mathphysics. In this video, we shall be looking at the equations of motion and their applicability. What actually is the equation of motion? When we talk about the equation of motion, we simply want to describe the position, the velocity or acceleration of a body relative to a given frame of reference. So we simply mean the position, the velocity, or what we call acceleration, of a body relative to a given frame of reference. And that's what we mean by the equations of motion. Let's say that a body or the force acting on a body is specified as a function of position, because we are talking about position, velocity, and acceleration. The integration of Newton's equation may be more difficult when a body is constrained to move in a specified manner on a fixed path. It may be possible to derive the position-time equation. So we can say that from this equation, the velocity time and the acceleration time equation can theoretically be obtained by the process known as differentiation. But for today's video, we shall focus more on the equations of motion and their applicability. If time permits, we shall also look at inertia. So now let us take equation. A body starts from rest. So let's have our number one question. The body starts from rest. And this body is moving in such a way that the distance covered by the body is directly proportional to the square of them to the square of 5. Then its acceleration is uniform. So this is the equation we have, that a body starts from rest and this body is moving in such a way that the distance covered by the body is directly proportional to the square of time. Then its acceleration is uniform. What actually is happening here Let us see what we are supposed to do. Solution. We know that V is uniform, meaning that V is equals to 0. This V1 simply means the initial velocity. So we are considering the initial velocity. By the laws of motion, using the equation of motion, we will simply use S because we cannot use the full formula here since no value was given. We are just told that the initial position of this body that starts from rest. It starts from rest means it is 0, so it is equals to a half at squared. And we know that the distance by the body is directly proportional to the square of time. So S is proportional to the square of time squared. This simply means that A is also constant. A is the acceleration and A is constant. And this is exactly how we interpret problems that involve calculations in equations of motion. If there were a value, we might have used the full formulas. We have S is equals to ut plus a half at squared. We also have other formula like v squared is equals to u squared plus 2as and many others. So you need to interpret, read the equation, go through it, and then you see the appropriate formula to use. Let us take another example. Okay, in the next example, let's take the number 2. A body is dropped from 2 different heights. If the ratio of the two heights two different height, that is height 1 divided by height 2. If this ratio is given by 1.2, then the ratio of the time Okay, so this is the question here, that a body is dropped from 2 different heights. If the ratio of height 1 by height 2 is given by 1.2, then the ratio of the time taken by the body to reach the ground is what? how can we find the ratio of the body to reach the ground? Let us take the solution of this. Since we are given height 1 divided by height 2, and this it has to be equal to the ratio of the time taken by the body, so we'll have time 1, t1 by t2 will be equals to height 1 by height 2. This will simply be t1 by t2 is equals to the square root of height 1 by height 2. We know that height 1 will be given by 0 because the value, the body is dropped from two different heights. So the initial position is 0 plus a half gt squared. If you don't know how we get this formula, kindly watch the previous video on the derivation of equations, tensions, and torques. So height 2 will be half gt squared. But we know that it is height 1 by height 2, so we will simply have this will be height 2 equals to half gt squared. We divide this so that this and this cancels, and then we have height 1 by height 2, which is equals to t2 by t2. So now this will be the solution, because the initial height for both height 1 and 2 must be equal to the ratio of the the time taken, that is t1 and t2. So this will be our solution. In the case where you are given variables, you will apply this formula and you are good to go in your calculation. Let's take another example. So let's take the third question, that the radius of the circle is increased by 20%. So if this radius is increased by 20%, then increase in the area of this circle will be what? What will be the increase? So we still have area solution. We simply have area to be equal to a half r squared. This is the formula for calculating the area of the circle. So we will have this therefore means that 20% by 20, and we are talking about area 25 by 20 plus 2 by 2. This will be 40 plus 4, so it will be 44%. 44%. And this is how we deal with the increase in the area of the circle, and how the area increase when the radius of the circle increased by some percentage. Hope you have enjoyed the video. In the next video, we shall be dealing with taking those displacement distance one by one and try to explain using calculations on what each of those terms mean. I'll see you in our next video. Stay tuned and don't forget to click on the subscribe button so that you'll be notified as we upload our subsequent videos. Galagash, God bless you.